So here we are given a surface whose graph we have no idea what it is, but we can still manage to find the graph of the tangent plane by thinking about the graph as a level surface of some function. All right. So first of all, you should think about what this means, the graph. What is a graph? Well, graph is you set the function equal to another variable to plot the points, right? And because I have x and y, we should put z. And since we have x, y, and z, this means the graph lives in the three-dimensional space. And since I'm given 1, -3, and it's some kind of a surface, I don't know. But what we're trying to do is I have this point, let's call it P, whose x coordinate is 1 and y coordinate is -3. And z coordinate I don't know, but it definitely has a z coordinate because the graph lives in three-dimensional space. And we're trying to find the tangent plane equation of this thing. Okay? So what do? We plug in, see the graph we're speaking of is really z equals to 3x plus 5xy squared. So we plug in 1 and -3, 1 and -3, 1 into all the x's that you see, and -3 into all the y's that you see. So you get 3 plus -3 squared is 9, 9 times 5 is 45. So I get 48. So that's the z coordinate. So the point P is really 1, -3, 48. We need that because in order to find the equation of the plane, we need a point and a normal vector. Okay? So we have the point, now we have to work for the normal vector. How do you find the normal vector? We use the property that gradient of a function is perpendicular to the level curves or level surfaces. We need the level surface. And what we do is we define capital F, x, y, z as the small fx, y minus z. Okay? So that in our context, it's 3x plus 5xy squared minus z. Okay? Now, why do we want to do this? We want to do it because if I set fx, y, z equal to 0, first of all, this is a level surface because I'm setting a function equal to a constant. So it's a level surface of this function at level 0. This could be 1, 2, 3, 4. But among all the possible values I can put on the right side, I'm interested in 0. Why is that? Because if I put 0 there, then I have 3x plus 5xy squared minus z equal to 0, which is exactly the same as the surface that we're playing with, right? So that's why we want to name this capital F, x, y, z as fx, y minus z, so that I can think of this as a level surface of this function. All right. So why do we want to think of it as a level surface? Because if that's the case, we know that the gradient of this function here is perpendicular to the level surface. So let's calculate the gradient. The gradient is, if I differentiate by x, it's 3 here, and then, what, 5y squared? And then if I differentiate by y, that's 0, but that's 10xy. And then if I differentiate this by z, it's -1. So that's the gradient. And then in order to find the normal vector at this specific point, what we need is gradient of f evaluated at that point, 1, -3, 48. Meaning that any x that you see should be replaced by 1. Any y that you see should be replaced by -3. And any z that you see should be replaced by 48. That's what it means. So let's move on. 3 plus 5y squared. So what do I replace y by? -3, right? So it's -3 squared is 9 times 5. It's 45 plus 3. Oh, it's 48. Okay, and then x should be replaced by 1. Y should be replaced by -3. So 10 times 1 times negative 3 is? Negative 30 and negative 1. That's the gradient at this point 1 comma negative 3 comma 48, right? And now we use the plane equation, which is a x minus x naught plus b y minus y naught plus c z minus z naught equal to 0. And that means it's 48 times x minus 1 negative 30 y minus this one negative 3 plus negative 1 z minus 48 equal to 0. That's the equation of the tangent plane. Once again, this is the plane equation. What is this a comma b comma c? That's the normal vector, and we're trying to use the gradient as the normal vector. So these numbers go into a, b, and c. Okay. What's x naught comma y naught comma z naught? That's a point, and we're trying to find the equation of the tangent plane passing through this point 1 comma negative 3 comma 48. That's why I plugged in 1, negative 3, and 48 there. Okay? That's how you get the plane equation.